So questions from the audience?
How does this deal with inconsistency in the knowledge base?
Yeah, so I guess, so it does have a, because it's a knowledge, it can handle the noise in the knowledge base, but to make it a little bit more concrete, so what our knowledge base is like I said, that list of generated facts. So we have like the knowledge base, and then you might have like fact A, predicate, or sorry, A, B, and within A and B, there's like a list of A is like X, a predicate X, Y, and B is X. And then within A, you have a list of X, Y assignments that where it's true, basically. And so what we're trying to do is we also then, while we have this kind of abstract tree, we have these,
Why don't you stop sharing the screen so we get it recorded?
oh, sorry. We have these are also kind of similar abstract predicates, and what we do is they call them generated facts. So we basically, there's a domain over P and Q of all the possible original knowledge-based predicates that can fit here. And so we take all of the possible facts from the original knowledge base and populate them in the abstract. And so basically what we're trying to learn is kind of the closest, the original knowledge-based predicate with the closest consistency here. So it is robust to consistency in that sense that it's more of a matching. Okay, I hope that answers your question.
So is consistency still part of the loss function?
So the consistency is part of the loss function in the sense that the final the labels for the target, so basically on the, over here.
I mean, in other words, is it treating consistency the same way as the base LNN framework, or are they doing something different?
It's slightly different because they're looking at the truth value predictions on the facts for the target predicate at the root of the tree.
Okay.
I think it was slide number 27. That you guys put a mu hat and a lambda hat. I don't know if I missed it, but could you please explain what?
Yeah, it's basically, so like they talked about they have to use ReLU and softmax to make sure that it actually fits into the Minkowski well. And so the hat is actually just the value before we pass it to ReLU or softmax, right? So it's essentially like in the case of softmax, right, it's unnormalized. In the case of ReLU, it is the full range of values.
So are those things in the boxes, the dashed boxes on that slide happening only in the forward pass?
Which slide?
Yeah, so this whole sequence here.
So they're layers that are learned, but they are applied in the forward pass.
Yeah. You pass a gradient through them, right? But you don't have to, I don't honestly know, but I don't think you need to write it in the backward pass. Although you are updating weights in the backward pass, so yeah.
Still
Yeah.
need. Do they have parameters themselves or no?
I don't think so. I think maybe I'm not sure if like you consider mu and lambda parameters. So I honestly don't know.
They are included as layers. Yeah. So I would assume that they do have parameters that are updated in the backward pass, but the optimization they provide becomes apparent in the forward pass. That like the optimization work is done in the forward pass.
Yeah, if you sort of look at the way it's structured, like basically, like he was pointing out, basically, like lambda mu could be parameters, right? It's like sort of a layer that maintains this constraint.
Any other questions? All right, let's thank the speakers.